let's try to solve another Leetcode problem. 16. Create a binary tree. So the description is really long, but I don't think it's too hard to understand. So for this problem, we have a binary tree with a small defect. So there is exactly one invalidated node where its right child incorrectly points to another node at the same depth, but to the invalid node's right. Yeah, so let's try to understand it. So in the first example, for example, this node 2, it is a defect node because this node connected to another node. Normally it should be in the next level, but it is in the same level, so this is a defect. And for the second example, for this node 7, it is the right child of node 3, but this node 7 connected to another node which is in the same level, node 4, so this is going to be a defect node. So if it is a defect node, what are we going to do? We just need to find the parent, which is node 3, and for this node 3, its left child gonna set to a none. Yeah, because those two will be disconnected. So that's gonna be the final answer. Yeah, because the final answer is gonna be node 8 with 3, 1, 9, 4, 5, 6. As you can see, 8, 3, 1, 9, 4, 5, 6. So this is gonna be the final result. So what kind of idea we can use to solve such kind of problem? First of all, we need to know if we find a child. So for example, this is a node 7. It can be at the left side or it can be at the right side. We don't know about it yet. So if it is at the left side, let's start to check this example. First of all, we need to find its parent, and its parent is node 3. Because if we find this node 5, if we are sure this is a defect node, definitely we need to find the parent, and the parent's left gonna equal to none. And second of all, we need to detect if this is a defect node. And how do we detect that? And we can use the level order traversal. So we're gonna traverse the node level by level. So before we traverse 7, actually, we're gonna put all those nodes like 8, 3, 1, 7, 4, 9, 7, 9, 4 inside a set. Yeah, so we put all those nodes inside a set. At the same time, in this level, 7, 9, and 4 would be inside a queue. So the node 794 would be inside a queue, and then I'm gonna pop out from the queue. So first 7, I'm gonna pop out from the queue. Yeah. So if I pop out from the queue, at the left side it's node 2, but at the right side it's gonna be node 4. So for node 2, it is not inside the set, but for node 4, it's already inside the set. So I'm sure this node 7 gonna be a defect node. And because I already know its parent is node 3. So 3 dot left gonna be equal to none, and in this way we can solve the problem. Yeah, now let's just try to solve the problem. So we're gonna prepare a queue, and it's gonna be a big queue, and inside it's gonna be tuple. So I'm gonna put the root node and the parent. So for the root node, the parent gonna be none, and I'm gonna prepare depth. You can set a 1 or 0, it doesn't matter, because yeah, even we set a 1 or 0, it doesn't matter, because we just need to check if that is in the same level or not. Yeah, I'm not sure if I need to use this 1 or not, but let's just get started. Yeah. Now I'm gonna check the queue, while queue for anything in range length of the queue. So I'm gonna pop out the node. So node gonna be equal to q dot pop left. So yeah, this is gonna be the basic pattern. So it's node dot left. So queue needed to append node dot left if node dot right. So queue needed to append node dot right. This is just like the level order traversal. Now what are we gonna do? We're gonna pop out all 3 variables inside of the tuple. First of all, it's gonna be the node, and then it's gonna be the parent, and then it's gonna be the depth. I'm not sure if I need to use this depth or not, but let's just check it later. Now, if we need to append something, it's gonna also be a tuple inside of the queue. It's gonna be node dot left, and the parent is gonna be the node, and the depth is gonna be equal to depth plus 1. And similarly, I just need to copy the node and the depth plus 1 to the node dot right. Yeah, now it seems everything is okay, at least for this kind of a level order traversal, but we didn't do any check, and we don't know what is the defect node. But now, how can we detect a defect node? As I said before, I want to put all those nodes inside a set, so I'm going to prepare a set. Inside, I'm going to put the root node. Now I'm going to put the node inside a set immediately if there's a left node. If node.left, I want to put it inside immediately. So the set needs to add the node.left. And similarly for the right side. So the set needs to append the node.right. Yeah. So I've already put everything inside the set. So for example, when my queue pop out to the node 7, so the node like 831794 has already been put it inside the set because according to my structure, I've already put it inside. So now I want to check it. So from where I need to check it? Yeah, because definitely it is the node right, because according to the description, the right child, as you can see, we are giving the root, return the root of the binary tree after removing the invalid node, and here there is exactly one invalid node where its right child incorrectly, so this is the right child incorrectly points to another node which is in the same level. Yeah, so it means from here I need to check it because this is its right child. Yeah, so if node.right inside the set, it means this is going to be a defect node. Because while I'm checking this node 3, actually I've already put 1, 2, 3 inside the set. So if it's right child inside the set, it means it is in the same level. So what I'm going to do? Yeah, it means I've already find that node 2 gonna be a defect node, and yeah, I need to let the parent node. I need to find the parent node. Yeah. So where is the parent node of this node right? So the node.right parent gonna be this node right. Yeah. So I need to let the node. This is going to be the parent. Node.left going to be equal to none. But is this true? It can be node.right equal to none. I don't know it yet. Yeah. But after I set it, definitely I need to break it immediately. Yeah. So here, if I find this going to be a node, and this going to be the defect node, and this going to be the parent, so the parent left and right going to be none. As you can see, the parent right should not be none. It should be a node 3. Yeah, but sometimes the node.right going to be none, but we don't know it yet. So we need to have another check. Yeah, but how can we check that? So we need to have a if check. Yeah. So if node so this is the node, and this is the node.right. So I think I need to have a check. If I don't check it, let me just try to submit it. Maybe sometimes it is from the left side according to the example 1 to 2, or maybe sometimes from the right side. Now let me just run it to have a basic check. It seems here is wrong. Let me use a tuple. Yeah, I get nothing because I didn't give a return. Let me just give a return. No. So this is my output 1, 2, 3, 1, 2, 3 now and 3. Yeah, it seems I didn't do anything about it yet, and I have to check that's gonna be a defect node. Yeah, let me check what is wrong. Yeah, maybe I would to check it from From here, I want to check what is inside of the set. Did I put something inside of the set? Yeah, it seems that there's something, all those nodes, I put it inside of the set. Yeah, it seems I don't need to use the depth, but I'll keep it there. So I prepared a queue and I prepared a set. It's gonna be the root node, and I'm gonna check the queue. I pop out the parent depth and the node. If node.left, I put it inside the set, and the queue I'm gonna append node.left with node depth +1. If node.right, I will append the node.right with node depth +1, and the set gonna add. Yeah, so I want to check if node.right inside the set. Yeah, let me just print out something to check if I actually get something or not. Let me have a check. Node.right.value maybe. Yeah, I want to check if I can get a node 2 or not. Yeah, it seems it is a check gonna be a check with 3. This is not. Yeah, because it's right should be 3, right? Because this is my node, and node.right should be 3. It seems okay. It seems that something about my check is wrong. Yeah. So if node.right inside the set, it means this node 3 inside the set, and this is my node, and I want to know my parent. Yeah. So this is my node, and this is the parent. So it means the parent.left should be none instead of a node. Yeah, this is why sometimes we want to print out something to have a tag. Now let me just submit it. It seems at least we passed some testing cases, but I believe we cannot pass all of them, because definitely the logic is not right. Yeah, because sometimes the parent left gonna equal to none, and sometimes the parent.right should equal to none. We don't know it yet. But how can we check? That gonna be a parent left or that gonna be a parent right? Yeah, it's just we need to check if this node 2 is a left node of the parent or if it is a right node of the parent. How can we check that? So if this is a parent, so we just want to check this node. Yeah, so if this node equal to the parent.left, so this means this node is going to be a left child. So we just need to have a check. Yeah, so if a node equal to parent dot left, this means it's going to be a left child. Of course, we're going to set parent dot left to none. So otherwise, yeah, I'm not sure if else works. Else, this means the node. Yeah, let me use if tag, maybe more safe. So if a node equal to parent dot right, definitely we want to set the parent right to none, and after that we need to have a break. Let me just run it again and submit it to tag. Yeah, as you can see, now it works. Yeah, I think the only difficult part is about these areas. Yeah, and about the design. Of course, we don't need to use the depth because I didn't use it. I use a set to tag. Of course, you can use a depth to tag, but I think the set is much more easier to tag. We just need to put it inside the set and check it. Yeah, or you can just use the depth to tag if it is in the same level or not. Yeah, but I believe the set is much easier. Even we use some extra memory, but basically the memory, the time complexity going to be O(n) and the space complexity going to be O(n). Yeah, and I like this kind of way of writing the code. Thank you for watching. See you next time.